Hey guys, so today we're going to do a videotape on field tiling, but to kind of understand what's going on, we need to first understand a little bit about soil water movement. If you've sat in one of my classes before, you've got to see this demonstration with maybe a bucket and a cup and a sponge. But think of this sponge as like our soil profile from top to bottom, and we're going to create some rain here. Hang on here. Wow, that was kind of frustrating. All right, so here we got some rain. It's raining. And, if you get a nice, gentle rain, that's going to, the rainfall is going to be able to infiltrate the soil, and you can kind of see it going down through, and that's called percolation. And when it reaches a point of saturation, water's just going to kind of start running off the top. And we're going to call that runoff. So think of soil as like a sponge. It eventually gets completely saturated. Now you're going to have some problems that happen with this, and one of the biggest ones is roots are going to start drowning in the water if there are any saturated soils, but also makes it difficult for farmers to be able to go in and do those soil operations. So we need a way to get this water out of the soil, and the way we're going to do that is by putting in field tile in the soil profile. So what a tile is going to be is basically pipes in the ground that are spaced at equal intervals apart, and they're going to have holes in them, and they're going to let the water kind of go into it. Now when we first start talking about this, sometimes people are worried that maybe that's going to drain the soil too much, but remember, soil is kind of like this sponge. It's not going to start losing water into that field tile until that soil is already soaked and holding as much as it can possibly hold. And you really don't need more than that, because then you just kind of end up with water sitting on top of it. You end up with like oversaturated conditions where it's just going to do, nothing but really cause you problems. So, just like right now, with a sponge, it's wet, and nothing more except for a couple occasional drips is going to be dropping out of it, just like soil going into a tile. But you can still see there's still a lot of water in it, just like a field would be if you had it drained. It's still going to be able to hold water and moisture up to the capacity of the soil, and the amount of that's going to depend on the soil's texture. Okay, so here's how our field tile arrives and shows up to the field in these great big rolls. And it's kind of good that this stuff happens to be yellow, because it's going to be real easy to pick this stuff out. You can see how it's got these different slots in it. And what that is going to do is allow water into this field tile once the soil that it's in becomes saturated. So remember, that soil is going to be completely saturated with water before you actually start to lose water or put water into this tile from our field. Okay, and in your field, this tile is going to come in obviously different sizes and diameters depending on how much water you're expecting to get out of it, the distance that the tile lines are placed apart from each other, and also the depth is going to play a factor too. But basically what you're going to have are these little tributary lines come from the side feeding a bigger line, or what we would call a tile main. So if I get a chance here today, I'll try to pull up the actual map and show you guys what this looks like. But at its simplest, that's what we're doing. We're feeding things from out of the field into a larger main tile, and that's going to be going to a drainage ditch to carry the excess water away from the field. Okay, so this particular farm is kind of interesting to me, because last year when I was planting it, it was half tiled, where I came in off of the road, and half not. So you could actually really tell the difference. It was a wet year to begin with, and you could just tell going across the field which spots had been drained and which spots had not. So right now we're starting to approach where some of the operation is actually ongoing, and I'm going to put this phone away for a second, because you can tell that we've got these big ridges and things out here that I need to pay attention to. But you can see the roll of tile on that cart kind of coming across, And our tile plow is sort of like center screen right now, but we'll get up close to this stuff here in a second so we can see how it works. All these ridge lines, if you can kind of see those going across the field, are where this machine has run already. And buried in the ground underneath this stuff is going to be the field tile, and that is going to drain all of our excess water off. Okay, so here's a little bit better view of it right here. You've got the main kind of running the same direction I've got my vehicle pointing. I'm looking out the side window here, so it's over there by the bulldozer. Then you've got these tributary lines that are all going to be going into and feeding that main tile line. So remember, these are already installed, and we'll get a close-up view of that here in a second, hopefully when this thing's working. And if I sweep over this way, hey, here we go. He's stretching out a tile line, and looks like we're getting ready to put another line in. Okay, so we're standing. If you kind of, look where the camera's pointed, of course, this is going to be one of the main lines, and running roughly perpendicular to it are going to be what we call these tributary lines. Or laterals. So these are going to be our laterals. And what we've done is drilled a hole into the main, and we've got this little tap that we can put into it. Oh, that's kind of neat. Can you see the water running through it?
Yep. And this is set to go right into the hole.
Okay, cool. And our lateral line will clip into that. All right, so the reason you got to dig out such a big hole is this tile plow, when we get started, has got to be dropped down into that hole so that it can take off on installing that lateral line. And all this stuff is planned out and mapped ahead of time. Not only do you need to worry about the location of the lines, but also you've got to worry about the elevation so that they can be, keep the water flowing and moving. So all that is controlled over here, kind of center screen. This is a laser, and that's going to be communicating with the tractor and the tile plow to tell us our elevation and control the depth that we're actually putting these lines in the soil so that water can flow through them right. Sometimes this thing's got to go in surprisingly deep because you've got to keep that tile on a grade so that it's losing, water, and water can run the way that you want it to run. But above ground or at the surface of the soil, you might have a hump of dirt that you have to go through while still keeping that tile underneath on grade. So you may have to really bury that thing to keep the water flow in the right direction if you have humps and things like that on the soil surface as that surface changes around. So kind of a neat process, and hopefully we can get started here in a minute and show you one of these things running. But there's a couple options. I mean, this is a plow, what we call a tile plow. And the other way to do this is with a trencher. And with both of these types, I mean, you've got the self-propelled kind that's like its own machine, or we have this one that's hooked up to a tractor here. But you can tell this is actually just going to be pulled through the ground and sort of dig its way through. You can tell how nice and tall that thing is, and then that tile is going to be feeding through the top of this here. Okay, so here's a little closer shot of our laser leveler, and that'll actually tell us our grade, and we've got this handheld control, and it'll match what the machine over here is saying. And you can actually, you said you can adjust it from this?
Mm-hmm.
Okay, so you can adjust it from here remotely, which is pretty cool.
We can be 1,000 feet away and adjust it.
Oh, okay, yeah, 1,000 feet. That's awesome. All right, so this is one of the lateral lines. It's already been installed, but here at the starting point, it's still open. And one interesting thing you can see is that it is already working. Where it's buried in the soil, it's got water coming into it. And actually here, where it's still open, it hasn't been buried yet, you can actually see water running out of that lateral line and kind of flowing along beside it. So that's just evidence that, yes, this thing is functional, and it's kind of amazing how quick this works because this thing was just installed not too long ago. Alright, so you see how this tile is fed through the boot and coming out of the bottom. And then it is going to get tied into the main where we put that coupler on it, or that connector, just a few minutes ago. And just like that, that tile plow is laying this field tile in the ground at the proper depth. And I think on this job, they got to put these lateral lines in. They were telling me every 50 feet. Right, so right here, you can tell that plow is buried really deep, and that's what I was talking about a second ago. You've got a hump here that we had to cross, and now you can tell it's starting to come up maybe a little shallower, but you've got to keep that tile on grade. This chain, they check it as they're going, and that just kind of gives you a visual reference of the depth, and it's got that flag on it, and the operator is able to watch that, and he's got these set points marked by these flags, and that's a visual check to make sure all the laser equipment and that stuff is working properly. It should be sitting at the same location here as it was at the last flag. Okay, so on the planned tile lines, you take this grade rod, and we're using this in conjunction with the laser down range. And if you get this set up right, it's going to beep at you, and it'll tell you the elevation. And this is something that you want to double check, because you want to make sure in the shallow dips that your tile is going to be deep enough, and you want to make sure that it doesn't end up too deep and like the hump. So here's a very crude diagram, but if you look, soil surface, and here's your tile, and the angles are all exaggerated so you can kind of see, but you may actually have to run a couple of different grades if the slope changes across your field. When you hit humps along the way, you may have to sink that thing really deep to be able to keep your tile on the grade. But at the same time, you've got to make sure that when you hit shallow depressions, like this one I've got scrawled out here, you have to make sure that your tile is not too close to the surface. So it looks like, just put the thing in the ground and go, but there's really a lot more to it than that. Oh, and to figure out where to set your slope at, you actually measure that elevation, using our grade stick and moving this piece on it here. It's so high I can't show you standing up right now, because you can tell 10 feet and then some, but you compare this at your different elevations, and then we can actually go through and we can calculate the slope to set the laser at that's going to control the grade when the plow actually goes through the ground. So there's a plan, and then you go back through and you manually check it, and then you use those manual checks to do the final calibrations on the equipment to get those slopes right. And then of course, in the actual field, you'll flag that off at different points. And you can see maybe some of these orange flags out here. That's how he knows where it's time to stop the tractor and then recalibrate the grade to go on the rest of the slope to keep the tile at the correct depth, so that again, we're maybe not going too deep in those deep spots, but keeping it deep enough in the little shallow dips. And it only takes about a foot to start throwing things off. If you've got a low spot that's a foot deep in the middle of this nice long straight run, you've got to account for that to make sure that, again, that thing is deep enough that it's A, doing what it's supposed to be doing, and then B, so you don't end up maybe accidentally snagging that with a piece of tillage equipment later down the road. All right, just like all dirt work, some poor sucker gets stuck here with a shovel, and we got to fill in the starting point, because what you don't want to do is just come in and shove all of this pile with these big chunks of clay soil right on top of this and put a big dent in it or pinch it off right before the outlet. So you've got to fill that in and put some things around it to protect it, and then you can take some equipment and fill in the hole. So one of the neat things is with our soil, some of the most productive soils end up in places that just have too much water, because remember, our clay is going to be hanging on to our water and nutrients, but it also can do that a little bit too much. So the color of this is an indication of, you know, good organic matter and good soil productivity. And just to kind of give you guys a sense of scale, I got my hand on that, and we have got a decent layer of topsoil here, and then it's going to change pretty quickly into our subsoil. And these different splotches of color you see are called mottling, and that's a sign of soil saturation. So if we can get the water off of this, the soil is going to be productive. We're going to extend the window that we have for field operations, you know, planting, obviously, and tillage work, and of course harvest with that. So we get increased productivity and increased time to do it. And another thing about this tile that we don't talk about a lot, it is actually going to be a little bit better for the environment, because then we can reduce things like that surface water runoff. You can't reduce it entirely. Obviously, if you get a big downpour, you know, you just don't have time for that water to infiltrate the soil. But it does kind of let our soil drain a little bit better and be better prepared to receive another rainfall. So there are lots of benefits to doing this, and it's kind of a neat thing. Hope you guys enjoyed the video today. I got to learn a few things today, and had a lot of fun making this. So until next time. All right, so one of the best parts about volunteering to help a crew out so you can make some videos is not having to be the guy in the shovel, but getting to be the guy that gets to play with the bulldozer and the backhoe and all that fun stuff. So I think all of us have got just a little bit of kid left in us, and we can agree that this is pretty cool.